So friends, since you know how to complete the square, you actually have a tool in your toolkit to be able to solve any quadratic equation in which you have a quadratic that you set equal to zero. So you can find the roots of any quadratic equation if you know how to complete the square. However, sometimes it's helpful or interesting to have a rule or a formula um, that you can use or apply. And so, for over many years, a rule has been developed, or a rule is developed, which is called the quadratic formula. And I would be remiss if I didn't mention the quadratic formula to you guys because it is such sort of a popular piece of mathematical trivia, and therefore you should know it. You should know the quadratic formula. But here's the interesting thing about the quadratic formula. I actually don't really care all that much if you memorize the quadratic formula, because I'd much prefer that you're able to derive the quadratic formula. In other words, be able to solve a quadratic in a general case to create the formula on your own, right? That's the real moment to show that you actually understand how this mathematics works. So I'm going to take a look at a quadratic equation, and it's in standard form. So I've got my ax squared, my bx, my c. A, b, and c are some numbers. A cannot be equal to zero, because if a were equal to zero, then I'd have a linear function. It wouldn't be a quadratic function, and none of this would be necessary. So there is that constraint on my equation. So with that in mind, I'm going to now use the method of completing the square to complete the square on this abstract form. I'm not going to plug in any numbers. I'm just going to complete the square of this form. So take a look at it. I've got a coefficient here of the x squared term, right? I've got an a. And so in order to complete the square, the first thing I need to do is I need to make sure I divide out that leading coefficient, which I am totally allowed to do because I've already said that a cannot be zero. So if I were to do that, I would end up with x squared plus b over a times x plus c over a is equal to 0 over a, or 0. Now I'm going to complete the square, so I need to move whatever this value is, right, over to the right-hand side here. And so now I've got x squared plus b over a times x. Leave a little space there because I'm going to complete my square with some value is equal to negative c over a. So now let's figure out what this missing value would be to turn this left-hand side into a perfect square, no matter what the terms were to begin with. So remember, I have to take half of this linear term, half of this linear value, and square it. So if I take half of b over a x and then square it, right? And this is just a little scratch so I can figure out what I've got. That would be b over 2a squared, which would be b squared over 4a squared. Okay, so I'm going to add b squared over 4a squared to both sides. Okay. And so this is now a perfect square, right? So I can rewrite this as x plus half of b over a times x, or b over 2a times x, and that quantity is, no x there, b over 2a, the quantity squared, And that now equals b squared. I'm just going to rewrite this order. So b squared over 4a squared. And if I take a look here, I need to have a common denominator in order to add these. So I need to make this one also be 4a squared. So since the denominator is currently a, I just need to multiply that by 4a, and I need to multiply my numerator by 4a. So that is minus 4ac over 4a squared. Okay, so again, just completing the square. So now I'm going to go ahead and actually I'm going to combine this side first before I go any further. So I've got x plus b over 2a quantity squared is equal to, these have a common denominator, so I can write them as both over 4a squared, and so it's b squared minus 4ac. And so I'm going to bring this up here so that you can see everything. And I'm going to take the square root of both sides. Okay. So if I take the square root of this side, I'm going to have x plus b over 2a is equal to, so I'm going to take a look at this side. So actually, if I look at this denominator here, this is kind of neat. 4a squared, I actually can take the square root of that. So 4a squared, the square root of that is 2a. But the numerator, I can't, that's not a perfect square. So it's going to be, the whole thing will be plus or minus. So the numerator is going to stay inside its radical, b squared minus 4ac, and that's over the square root of 4a squared, which is 2a. Okay. And so now I just need to move this b over 2a over. So I'm going to subtract b over 2a from both sides. So now x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac also over 2a, which is pretty cool because that means that these actually have common denominators. So since they have a common denominator, I can write it as one whole fraction, and x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, many people will encourage you to sing a little song, maybe because they're so excited when they finally show that they're able to do this. They're like, look, I know what x is equal to, and they just burst into song. So the traditional, the classic version, shall I say, is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, which is a rather old ditty. I'm not sure how old, but it to Pop Goes the Weasel. So feel free to sing that one, or I set it to Bruno Mars's Happy a few years ago. It works pretty well. X is equal to negative b plus or minus the square root of b squared minus 4ac all over a times 2. That's the same as 2 times a because it's commutative. But anyway, that, I guess it's been a few years since that was a thing. So feel free to come up with your own version to sing it. The singing helps you remember it. Because, it's not the kind of thing that you just wake up in the middle of the night being like, oh, I really got this. So you're going to have to come up with some way to memorize it, or just be confident in knowing how to derive it. All right. Have some fun plugging in and using the quadratic formula. Thanks.